can become unruly. So rather than every line coming from data partition node, I create this and I make lines going from here. So it's fine. This is just a connecting point. Huh? It's just a connecting point. It's not doing anything. So rather than making every line go to assessment, I'm just connecting them all here and taking one line from here to assessment. Okay, so this is just so that your diagram doesn't look very messy.
You don't have access to this side of the line. You mentioned rapid miner. Would that be a good substitute?
Okay, like rapid miner would do this part pretty nicely, the decision tree part. But when we do, the clustering and the decision trees together, it doesn't do all that. But this is the process. The process, now remember, when you do this, what are the outputs you're interested in? I need to get accuracy. Can I get that? For simplicity, I need the number of leaves. Can I get that?
Yes.
Can I get the lift value for each of the models?
Yes.
I can do that. Can I get whether it's stable? Right? So I can get numbers for all of them. Then also can I get the output? I can get the output in terms of the reporter node, which is nothing but a...
The lift values is for each model.
If everything is in the reporter node, then it's nothing but a file that you can just copy, right? And I made it too big so you can see and all the models are in here. So I have the English rules for the first one, and then I will also have the English rules for the... There we go. This is entropy 1%, right? Oh no, this one didn't. This is
This
an
is
old
old
one.
Roll. Also explore the use of one or more derived attributes. So that means you may specify one value function.
The both things. I think I know what I did. The last control point thing remember these four models are just let's hope it does it now. Did I do that? I didn't know. I just did open last time maybe.
That's when I put no.
Just 0 1. Just an observation, yeah. Okay, see now it's done the whole tree, right? All of them. So this is for Genie. There are two other, they're repetitions, so you can get English rules for Genie. Remember, Genie is very similar to what you're getting before. Actually, let me change this one to
Chi-square. No.
Okay, these are also, it's little different than the other two. Little different, but not so much. I don't know. Remember, these are all cleaned up nice data. When you work with real data, you won't get anything like this. Let me close this diagram and open something. Close this project.
That's why I didn't use control buttons.
I did not. I did try to use it in the end. I did use it.
Oh.
Okay, open it.
Oi.
Yeah, this is a nice one.
Whoa. What variation? What variation?
This is good to show you variation, huh? Now, look at the light blue one and the purple one. Is the light blue one stable? Going down, that's fine. The
Going
top
down.
ones are performing well, and then slowly the later ones are not performing, which is fine. Look at the purple one now. So the purple one is the one which is, even this blue one. In the purple one, it is more dramatic. In this one, it is not so dramatic, but this is also unstable. So, but if you look at this one now, the lift of probably the purple one is the higher one. So on one performance measure it is doing well, but on another performance measure actually we are saying it may be an unstable model. So should we be taking purple one or should we be taking this brown one? Which are different models here. I was just showing you sometimes with nice clean data, it's hard to see the variation, but when you have real data, you will see these things happening. Yeah. So now here if you were to look at the lift for the purple one is probably higher than the lift for the blue one, isn't it?
Yeah.
So, but if you were to look at stability of purple one is poor compared to stability of the blue one. So you understand that you will have to now fill out a table with all the models and their 4 performance measures. Then you need a weight, that which one is more important. Accuracy has to be the most. And then you have number of leaves, you have you have stability, you have lift value, and with that you will get one composite score, and from that one composite score you will determine that of all these models which one should I use. I wouldn't say which one, I would say which is the best set from here. So then the decision maker can see which ones have more practical value, right? These have more value in a modeling perspective, that they're all stable and sound models. Then, from a practical perspective, what can I even act on? Maybe some they cannot act on, some they can act on, and then they can make the decision. And so that's why we give not just one model, we give a best set. Fine? And now you appreciate that if you were not following a methodology, like a crisp DM, then you would have problems in now saying which model should I be taking. When do you set that these are my performance measures? What are their value functions? You set that earlier on in life. And then when you do the modeling, you do the evaluation, and then you can put it into real world. So, Tuesday then? But it's a good thing you asked me to do the demo because it was not completely wasted.